Oftentimes in probability, you'll find that you're actually just doing a counting problem. And where it gets interesting is when you have to count a huge number of numbers and make some kind of an estimate on it. Now, you'll see here in this problem, I'm told I want to know how many numbers between 300 and 699, including the ends, right? 300 is okay, 699 is okay. How many numbers in that full span do not have the number 1 included as a digit? Okay, well, let's take a look at this list. I've written some of the numbers between 300 and 699 here. And you can see that 301, no good. 310, 11, 12, oh, those are all bad. There's a lot of bad numbers right there. And then 321, that's another bad one. And we could go on like this for a while, right? But let's try to not write 400 numbers down and see if we can figure out a pattern instead. So I want to just look at these things grouped. And I'm going to say, let's look at the first 10 numbers, and the second 10 numbers, and the third 10 numbers, and so on. All right, well, how many bad numbers are there in this first set? There's only one, 301. Okay, so that's your problem. In the second set, how many bad numbers are there? They're all bad, right? 310, 311, 312. They all have the digit 1 in the tens place. So you've got 10 problems there. In the third set, we're back to 1. And it'll be the same for all the other sets in the 300s. 330s, 340s, 350s. The only time you're going to have a problem is when it's 351, 371, and so on. So, if you look at the 300s as a class, how many problems are there in that class of numbers? Well, there's going to be, here, let me do it this way. In the 300s, you've got 1 problem. In the 310s, you've got 10 problems. In the 320s, you've got 1 problem. In the 330s, you've got 1 problem. You see, we're back to another style of counting. This time we're counting by tens. And eventually, you'll get to the 390s, where there is just 1 problem. You add them all up, and this is 19 total problems. In other words, these are numbers we cannot have in the range 300 to 399. Okay? So that's nice. And now what we have to do is figure out, can we extend this without counting more? Well, that means we're going to have 4 times 19 problems between 300 and 699, right? Because that's 4 sets of 100. You're never going to have the number 1 in the hundreds place, because we started at 300. We did not start at 100. So we've got how many problems here? Well, 4 times 19 is 76. So there are 76 numbers we are not allowed to have. Remember what this problem is asking. It's not asking how many issues there are. That's not what it wants. It wants to know how many numbers do not have the number 1. Well, there's 400 numbers total, and there's 76 that I do not want. Okay, so that's my chance of success right there. And the total number of numbers is 400. So here's what we've got. We've got 324 chances for success out of 400. In other words, I've got better than 75% odds at choosing a number randomly which does not have the number 1 in it. Okay, and that is about the quickest way you can go through this problem. We're counting, but we're also looking for patterns.